Hello! Hello, algebra students. Mr. Lawrence here, and today we're going to talk about solving systems of linear equations by graphing. Now, this is a good way to do it. The problem is sometimes it's not a good thing because you won't get a specific answer. It's a little hard to be specific. But I will tell you that some of you came up to me at the end of class, and many of you had the right answer. Colin came to mind, Disha came to mind. And by the way, Madeline came up and asked a really good question. Hopefully we'll talk about that in class tomorrow if we remember. Remind me about that, Madeline, because it was a very intelligent question. In the future, I'd love for you to ask that question during class so that we can have a discussion about it. All right, so let's get on to this solving systems by graphing. Solving systems by graphing simply means we're going to have more than one linear equation. Well, it doesn't have to be linear. These will be linear, but in the future it won't be limited to linear equations. And we're going to graph them and find out where they cross. The solution set that Kelsey was trying to talk about, or the specific x and y values that Lainey was trying to talk about, I was playing kind of dumb, trying to get as much out of you as I could. You weren't really that far off. It was pretty intelligent thought, ladies. We're just trying to find the coordinates of where these two lines cross, the point where they cross. So let's graph this first one. It's in slope-intercept form. And by the way, I know some of you don't know slope-intercept form yet. Shame on you. You better get in here and get some help on it. It's too simple. All right, my y-intercept is going to be 1, 2, 3, 4, 5. Okay, and then my slope is negative 3 over 2, so I go down 1, 2, 3, and then right 1, 2. I'm going to go down 1, 2, 3, and then right 1, 2. And I'm going to put a whole bunch of points on here because I'm not sure where these two lines are going to cross. And I'm not going to draw my line in just yet. 1, 2, 3, 4, 2. Okay, and that's all I can put on right now. And now I'm going to do the blue one. And now the blue one's not in slope-intercept form. I would not go to slope-intercept form on this one. I would find maybe the x-intercept and the slope. So the x-intercept is going to be c over b, right? And excuse me, c over a, 0, and ABC, ABC. A is 2, B is negative 1, and C is 2. So that's going to be the point 1, 0, right? If I do 2 divided by 2. So 1, 0 is right there. And then my slope, I'm not going to find the y-intercept in this one. I'm going to find the slope, which is going to be the negative of A over B, and that'll be 2 over 1. Sorry, 2 over 1. So I'm going to rise 2, run 1. Oh, look at that. I found where they cross. This is why I don't like to draw the line first. I like to see if I can tell where they're going to cross. I just kind of got lucky. I used the x-intercept and I counted slope. And sure enough, there it was. That's the place where the two lines cross. And that is what we are after. And I'll make my lines a little bit thinner here. Put them on a diet. And let's see here. That's my blue line. The blue line. Okay, that's what I take to get downtown when I take the rapid. And I need the green line. I don't know where the green line is. Must be in another part of town. All right, let's see here. The green line, line, everywhere a line. Sorry, got a song stuck in my head again from the other day. Green line, give it an arrowhead. And it is clear on this graph that the solution to this system is the point 2, 2. That's the place they cross. Yeah, it's pretty simple stuff. Let's do a couple more. In fact, if you'd like to, go ahead and pause the video. See if you can do it on your own, especially those of you who are really good at graphing. Go ahead and do that. Get ahead of the game. All right, this one, I'm going to go to slope-intercept form, and it's going to be y equals 3x minus 5. All I did was subtract 1 from each side. So 1, 2, 3, 4, 5. My y-intercept is at 0, negative 5. And my slope is 3 over 1. 1, 2, 3, 1. 1, 2, 3, 1. 1, 2, 3, 1. 1, 2, 3, 1. And there we go. So, like I said, I'm not going to draw my line yet. I need a green line first. See if I can get lucky again and find out where they cross. This one here, I guess I could go slope-intercept form. Or it might be easier to go standard form on it. I think I'm going to go standard form. So I'm going to have x plus 3y equals 15. I think I'm going to graph this one by intercepts. Okay, so the x-intercept is going to be 15. Oh, bad idea. Maybe I won't go x-intercept. I will go y-intercept, though. The y-intercept is going to be 0 c over b. So my y-intercept will be the point 0, 5. So 1, 2, 3, 4, 5. And then the slope is going to be negative 1/3. So I'm going to go down 1, run 1, 2, 3. Oh, look at that. I crossed it again right away. 1, 2, 3. I'm ready to draw my lines. I know the solution is going to be 1, 2, 3, 1, 2, 3, 4. Now, some of you will be thinking to yourselves, Colin Peretti, that, you know what, I know where they're going to cross. Is it really necessary to draw the lines? Well, it is if they ask you to solve the system by graphing. If they just say solve the system, and, you know, in other words, just tell me where the two lines cross, then I guess it wouldn't matter. You wouldn't have to graph both lines. But if it directions say to solve by graphing, then yeah, you do need to. Okay? I've forgotten which one this is. This must be the green line. No, this is the red line. There we go. All right. So I know that runs to the east side from downtown. Windmere, I think. Okay, anyway. So, I need a red line. No, I need a green line. Green line, green line. And there we go. Let me just finish graphing so that it looks pretty. It looks pretty, oh so pretty. And there we go. Okay, it's off a little bit just because of my own carelessness. There, now it's even better. All right, so pretty simple stuff. Here's another one. Go ahead and try to see if you can do this one on your own. All right, this one here, the red one, x has to be 6. 1, 2, 3, 4, 5, 6. 6, 0, 6, 2, 6, 5, I think. 3, 4, 5, yeah. That's going to be a vertical line. How do I know that? Because x has to be 6 no matter what. There's no other possibility. How do I know? The equation says x equals 6. X must be 6. Can't be anything else. All right, properties. I'll make it red, and there we go. All right, this one here. Uh-oh, I left the variable out. I think I want the variable to be on the 4. Sorry about that. Okay, this one, well, there's a couple choices. I guess the standard form would keep me from, well, yeah, standard form could keep me from dividing. So I'm going to subtract 2y from both sides. And when I do that, I'm going to get negative 5 equals 4x minus 2y. Am I in standard form? Yes, I am. We're used to seeing it as ax plus by, y equals c. And it's written as c equals ax plus by. But those are in the same equation. So a, b, c. Easy as for negative 2, negative 5. Okay, I don't like any of these points. Yuck. Already tested them. I think I'll go with the y-intercept. The y-intercept will be the easiest one to do. It's going to be 0 and negative 5 divided by negative 2. Okay, which is 0 and then 2.5. That's not too bad to graph. So go 0, 1, 2.5. So it'll be about halfway right there. Now my slope is going to be 2 over 1, I believe. Negative 4 over negative 2 will simplify to 2 over 1. So we're going to go 1, 2, 1. Go up 1, go up 2, and then over 1. Go up 1, 2, go over 1. 1, 2, over 1. Uh-oh, these aren't going to cross on the graph. Whatever shall I do? This is the problem with solving by graphing. Something's going on here. We got a little possess smartboard happening. All right, let's put all those together. And let's unlock him. All right, see if we can't grab them together there. And I'm going to lower this. There we go. And see if I have some plain old graph paper here. Is it the same size? Yeah, I think it is. Hopefully. Yeah, it looks like it's off a little bit. A smidgen. No, that's pretty close. All right, so then I'm going to go, what was I doing? A slope of 2 over 1, I believe. Yes, so 1, 2, and over 1. 1, 2, and over 1. And that's going to be the place they actually intersect. 1, 2, and over 1. All right, so I'm going to draw this line here like that. And this red line is actually going to have to be extended, isn't it? Let's see, let me ungroup all of that. And I need to ungroup all of this. Oh dear. And then make him longer. And so they're crossing at this point here, which is going to be the point 6. And then, let's see, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 6, 15, and there you go. Okay? So that's the problem with graphing. It doesn't always fit on your graph. It's not as pretty. And then sometimes it's really ambiguous. Like that one, I could tell where they cross. Try this one on your own. Everybody should be trying this on your own. You should be graphing this. No excuses. Okay. So we're going to go 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4 right there. Go 1, 2, 3, 1, 2, 3, 4 right there. Okay. So the y-intercept is going to be 6. 1, 2, 3, 4, 5, 6. And the slope is going to be 2 over 1. And I'm going to use the negative version of the slope. And look, my lines will have already crossed, but I don't know the exact location. I don't know the coordinates. I can see where they cross, but I can't tell exactly where they have crossed by coordinates. I can only get an approximation. In fact, I'm going to go ahead and get the graphing calculator up here in a second. There's that green line. I should make him thinner. It looks more accurate when it's thin. There we go. Okay, and now I need a red line. So I'm going to make him, first of all, red, thinner, give him an arrowhead at the beginning, and let's make sure he's lined up. Yeah, it's close. It's pretty close. It's hard to be perfect. And look at this. It's somewhere in this region. Okay, the x value is close to -2, but not quite, like -1.7 maybe, 1 7/10. And the y value is going to be like 2 4/10 maybe. It's very difficult to tell. So what I'm going to do here is I'm going to bring up the graphing calculator and put the two equations in. They're in slope-intercept form, so this won't be a problem. Okay, don't worry about that. I just turned my airliner off. And let me get the new equation. Let me clear out that one. And let's see, the first equation was y equals -3/4 x. So I can go -0.75 because I know that's the same as 3/4 if I want to. If I don't want to put the fraction in there, I can do +1. And then the second equation is going to be 2x plus 6. I wonder if I can change the colors of those to make them match. Let's see, I'd want that one to be green. Yeah, I can. That's pretty cool if you think about it. Let's see, I want it to be green. You have to look into how to change that. It doesn't seem to want to let me do that. All right, now I can't get out of there. Okay. All right, so there's my two lines. I'll do a zoom 6 to make sure I'm looking at the right part of the graph. And here they come. Okay, it looks like they're crossing right there, doesn't it? I'm going to hit trace. Okay. And I'm going to try to get where they're right on top of each other here. And it looks like it might be about negative 1.8. Okay, let's do this. Let's type in negative 1.8, 1 and 8/10. Notice I'm on the blue line. And I get 2 and 35/100ths. Now, let me move to the red line by pushing either the up or the down arrow. Okay, it looks like I get negative 1 and 8/10. And notice it's not quite right. I'm close, but I'm a little bit off. I think that it was telling me the actual place of intersection here. Yeah, I think that might be it. The 2 and 36/100ths repeating. Let's see. I'm on the red one, right? And I'm going to push the up arrow or down arrow, and that will send me to the blue one. Let's see if the y coordinate changes. No, it stayed the same. That must be where they intersect. See that? I'm on the red equation. How do I know? Because it says y sub 2 equals 2x plus 6. And then I'm on the blue equation, the negative 3/4 x plus 1. And notice the x values and y values are the same. So that's kind of a cool thing you can do with the graphing calculator. Anyway, I am going to wrap this video up. Mr. Lawrence signing off. Have a good night, everybody.